Hey there, IT 140 students. So in this recording, we're going to talk about decision structures here in chapter 3. So we start out here with the idea of how do we make decisions in our code? So most programming languages, Python included, provide ways of using an if-else branch to handle conditions. So let's kind of scroll down here. So the ideas look something like this, where we have an age value and we check if the age is greater than 60. So we're going to make a decision. So if the age is greater than 60, then we're going to do something. In this case, they get a 20 bucks off. Otherwise, if their age is not greater than 60, they don't get the $20 off. Okay. So keep in mind at its most simplest form, we just ask a question if and then some kind of logical situation. Here, the idea was age is greater than 60, and then we perform some kind of action. Another example. So what if we want to check if a value is negative? So we ask the question if value is less than 0. So if that's the case, we know that it's a negative number, and we may want to make it so it's non-negative. So they're going to multiply it by -1, and now it is a positive number. So the main thing I want you to understand is the condition that we check. So we check a condition, and then we perform some action based on that condition. Now, that was if we only have one condition going on. If we have two things that we want to handle. So here we have a weight, and if our weight is less than 150, then they can do something. Apparently they can ride something. Otherwise, they can't ride. So what's the case that gets right here? It wouldn't be 149, wouldn't be 148, because those are less than 150. So if you're thinking values like 151, 152, and so forth, you're thinking on the right track. But what about 150? Is 150 less than itself? And the answer to that is no. So if you wanted to include the 150 right here, this would need to be weight less than or equal to 150. So this is all cases less than 150. This is all cases 150 and beyond. So some notation that you're probably familiar with from in your math classes. The first one would be something like this, where it's, negative infinity to 150. Again, we would use open parentheses, not brackets. And then the next case would be 150 to positive infinity. So negative infinity to positive 150. Again, no close brackets. And then this other case is I get to include the 150. Okay. So we have to be able to think logically here. Anytime you're going to make a decision, there's a potential for an error there. So always make sure that your logic is correct. Um, Instead of just using numbers, we could compare variables. So we've got X and Y as inputs. So this would be checking if X is greater than Y. So that means X is the maximum value. Otherwise, the maximum value is Y, so we're trying to get the maximum value here. What if X and Y are the same thing? The maximum is X and Y, so it wouldn't harm this logic right here. It's all going to work just fine. Now, the next idea is, what if we have multiple conditions that we want to handle? So for instance, what if the year is 1984? Well, that's a book written by Orwell, so we would output Orwell for that. Otherwise, what if the year was 2001? Well, that's the 2001 Space Odyssey science fiction. So we would put Space Odyssey for that. Otherwise, we put nothing special. So keep in mind, we can have multiple tested conditions here. And then these else blocks here catch everything that gets through. So I know this is a lot of logic to put in here, but all you have to be able to do is figure out what do you want to check conditions on. And then for this example, it didn't matter which came first, but later down the road, the order in which we check things will potentially matter. Okay, so let's go to the next section. So now we're going to see it in Python code. So we've got a user age value that's getting input, and we're checking if the user age is greater than 65. So this is just like the math classes that you've always been familiar with. What is different is we have an if statement. So if, and then variable greater than 65, and then all if statements are terminated with a colon. So that stops that this is a tested condition. And then the next line down is indented. So this becomes a code block. So if you do not indent this, then this is not going to execute based on the condition. And again, what we're doing here is if they are greater than 65, then they get $20 off. So why don't they just simply write it like this? So age is always an integer value. So they could have written it user age greater than or equal to 66. Both of these are going to perform the exact same. So we can also have an else block. Again, as I mentioned in the intro, the else block is going to catch any conditions that don't get met. So we start out here if user age is less than 25. So all ages from 0 to 24 are going to have an insurance price of $4,800. And then, oh, hey, you turned 25. Now your insurance goes down to $2,200. So anybody over the age of 25 gets this insurance price right here. Keep in mind the syntax, colon, and then same thing with the else, it has a colon, and you have to indent your statements. Typically, the indentation is 4 spaces. And just like we saw in the introduction, we can have multiple tested conditions. So here's the first tested condition, just like we saw in our last code snippet. Else if is shortened in Python to elif. So here would be the next tested condition. And I can have as many elifs as I want. You can have one if, you can have as many of these, and you can only have one else. Keep in mind the else always has to be at the end, and these tested conditions have to be logically correct for what you're trying to do. So here, the order of these doesn't matter, but it makes it nice that they're in a numerical order, because if you've been married 1 year, great. If you've been married 10, impressive. If you've been married 25 years, hey, it's your silver anniversary, you get silver. If you've been married for 50 years, then it's your golden anniversary and you get gold. Fantastic. Again, we could have switched these up any way that we wanted to. It didn't necessarily have to go in order. Um, Anything that's not a 1, 10, 25, or a 50, it's nothing special. Okay, next thing here is we can nest statements. So we can put if statements within if statements. So the idea here is we're going to make a user choice. So there might be some menu, okay? So, they might have a menu printed out, one, option one. I don't know, let me just make up Big Mac. 2 is a, quarter pounder. 3 is whatever, chicken nuggets, okay? So we display a menu to the user. And so if the user choice is equal to 1, so to compare if something is equal, we use double equals. Well, okay, so great. We chose 1, so here it is. Else if user choice was 2. And again, I can have as many elifs as I want to handle whatever conditions I need to meet. But then look inside here. So maybe choice 2, they were purchasing something. So now I can go look to see, well, how many items did they choose? And I can handle how many items they chose properly here. So if it's less than 0, that means they didn't choose anything. Otherwise, yep, they chose something. Okay. Are you always going to have nested statements inside of other things? No. The beauty about computer science, the beauty about writing code, is that you can structure things however you best see fit. All right, so I mentioned earlier that the order in your if statements sometimes matters. So let's take a look at this example here. They're using separate if statements here. And so if your user age is less than 16, then you're going to be told enjoy your early years. If your user age is greater than 15, so this would be 16 and above, you're old enough to drive. Here, you're old enough to vote. Greater than 24, well, car rental companies will rent to you. And if you're 35 or older, you can run for president. So these are different situations, but if they were all going to be related to just one thing, if we had these as else if statements, we'd want to make sure that our logic is 100% accurate. All right, let's go to the next section. So I already just mentioned to you to check if two things are equal, then we use the double equals operator. If you only use the one equals, Python's not going to complain about it. It's just not logically going to be reading anything. To check if two things are not equal. So you might want to check if something is not equal to 3 or not equal to 4. Then you use the exclamation equals. So to check if two things are equal, to check if two things are not equal. I've already mentioned and we've already seen them. So you've got the relational operators, less than, greater than, and so forth. And it always works with, just like in mathematics, you're reading them left to right to determine the logical condition that they have. If you're going to compare characters or strings, keep in mind that the strings or the characters have to either be in double quotes or single quotes. Otherwise, it's going to be an error. And then the relational operators work for integer, character, and floating types. The floating types are sometimes not the most accurate because of the way things get stored in computer memory. But we're not going to worry about that too much for our class. Okay, next thing that we can do is we can have a new data type of Boolean as a variable. A Boolean is just a value that's either a true or a false. So we can say my underscore bool or whatever variable we want it to be, and we assign it equal to true. Note that there are no quotes around true. By making it no quotes, capital T true, or capital F false, this means that that variable is a Boolean and it can be read as a Boolean. What does that mean? Let's see down here. We should have some code where I can just simply check my variable condition. I thought it was in here. I will throw it in the notepad. So I could do something like this. I could ask if my bool equals true, or I could ask if my bool equals false, or I don't even have to check if it's the double equals true. These are equivalent. If my bool, if not my bool. Let me see here. I got to remember my Python syntax. Hang tight. Yep, I was right the first time. I could have just simply said if not my bool here. Okay, so nice shortcut methods. It's always nice logically thinking out to specify it, but once you get going, you don't need to specify the equals true or equals false. You can use these syntaxes right here. Now, one thing that we might want to do is put several conditions together. So in Python, we can put together two tested conditions by using the AND operator, where this is going to check that everything that we put together is true. The idea here would be something like this. Let's say that the age is greater than 16 and the age is less than 25. So that means we're what, between 17 and 24? So that is true if we're 17 to 24 years old. Look at this condition. We might have age greater than 16 and days greater than 10. So we've got two conditions that are being tested here. And in an AND situation, every tested condition in this has to be true. So if there's anything that's not true about this statement, then it would be a false result. So if our age is 19, hey, this first one, we're good. We're between 16 and 25. Here, we start out age greater than 16. Yes, we're 19, but the days is 7. That would result in a false. So this is not true. All of them have to be true in an AND situation. In an OR situation, at least one of them has to be true. So are the age greater than 16? Yes, it is. Are the days greater than 10? They're not. But this condition right here is true. So as long as one of them are true in an OR statement, then the whole thing is considered to be true. And again, we just mentioned I can use the not. This is going to be the reverse. So days greater than 10, I want the reverse of that logic. So what's the reverse of days greater than 10? That would be days less than or equal to 10. So why not just write it that way? That's a way better to write that, okay? So the good usage of the not operator is things like this right here. A nice thing that we'll use quite a bit when we get to some lists or dictionaries in our course is the in or not in operator. So this is creating a list of values, and I can use the in operator to say if something is in this list, and it will return a true or false back to me. So for instance, we have a football roster here. So we've got these names, and I get a name input in from the console, and I can check to see if that name is in that list. If it is in there, then great. Otherwise, it's not in there, okay? Likewise, this is the reverse logic of that. Now that we've got quite a bit of arithmetic rules and we've got some logical rules, keep in mind here in 3.7, there is an order of evaluation. Parentheses, arithmetic, always get performed first, just like in your math classes. And then next thing that happens are any kind of comparisons, nots, ands, and ors. And that's all I want to talk about there. Last thing, so as you're writing your if statements, as I mentioned earlier, your if statements define a code block of things that you want to perform based on that condition. And the indentation needs to be maintained throughout. They say either 3 or 4. It's pretty typical that it's actually 4 in most Python development. So make sure that you've got your tested condition. The block of code that's associated with it is indented and maintained the whole way. And if you have nested conditions, make sure that you nest and have the proper indentation. And okay, so that's it for chapter 3. I know it's a lot of logic, but make sure as you're working, think logically. Make sure that you are thinking simple. And if you have any questions, don't hesitate to reach out.